Hi everyone, this is NLP Corgi. Today's deep dive is about the paper from Google translating step by step, decomposing the translation process for improved translation quality of long-form texts. Machine translation has long been treated as a simple mapping. You feed in a sentence in one language, and a system spits out its equivalent in another. That view made sense for older statistical and neural systems, but large language models open up a different way of thinking. Instead of a single leap from source to target, we can model translation as a process, closer to how humans actually work. This paper proposes a four-stage step-by-step framework for translating long documents with an LLM and shows that this process can significantly beat standard one-shot prompting. The central idea is simple but powerful. Don't ask the model to translate a long document in one go. Instead, walk it through the same stages a professional translator might follow. First, do pre-translation research to identify tricky parts. Second, produce a faithful draft. Third, refine that draft for fluency and readability. And finally, proofread the refined text for a polished result. Each of these stages is implemented as a separate turn in a conversation with Gemini 1.5 Pro, so the model can build on its own previous work. Translation studies have long argued that humans don't just convert sentences word by word. They research, draft, revise, and proofread. In parallel, the LLM community has learned that chain-of-thought prompting, breaking tasks into steps, often boosts reasoning quality. Several recent papers have tried to exploit this for translation, but most focus on either pre-translation hints or post-translation editing, not the full pipeline. This work asks a broader question. If we explicitly model the entire translation process with an LLM, do we get better translations, especially for long-form text? To situate this work, the authors survey recent LLM-based translation methods. Many approaches focus on post-editing. They take an initial translation and ask the model to fix errors, often guided by external quality estimation metrics or human error labels. A smaller set of methods explore pre-translation research, like generating background knowledge or idiom explanations, but often still rely on external tools to pick the best output. Only a handful of studies attempt to model the full translation process, and those can be quite complex. In contrast, this paper proposes a streamlined four-step pipeline that covers both pre- and post-translation stages, and crucially, uses only the LLM's internal knowledge, no external QE models or retrieval systems during translation. The first stage mirrors what human translators often do before writing anything. They scan the text for trouble spots. The model is given the full source document and asked to find phrases that would not translate well, word for word, into the target language. These might be idioms, slang, figurative expressions, or culture-specific references. For each phrase, Gemini explains the meaning and suggests appropriate translations. This research output is then structured into JSON, so later stages can easily reuse it. Once the model has thought through the tricky parts, it moves to drafting. Here the instructions are clear. Focus on adequacy. The draft should capture the meaning of the source as closely as possible, using the research artifacts to handle idioms and difficult phrases. The model is told not to add extra commentary or alternatives, just one coherent draft translation of the document. The third stage treats the draft like a text that needs editing. The model is asked to refine the draft, focusing on fluency and readability in the target language. This is where awkward phrasing, translation ease, and clunky sentence structures are smoothed out. The instructions still emphasize preserving the original meaning, but now the goal is to make the translation read as natural, standalone text. The final stage is proofreading. Here, the authors deliberately start a new conversation with the model, inspired by the idea that human proofreaders benefit from a fresh perspective. Gemini is shown the source text, the draft, and the refined translation, and asked to deliver a final, polished version. The focus is on catching remaining grammatical issues, punctuation errors, and terminology inconsistencies, while ensuring the translation still reflects the original meaning and style. During development, two design choices turned out to be crucial. First, working at the document level, rather than on isolated sentences, made a big difference. With more context, the model could correctly disambiguate phrases that looked idiomatic in isolation, and could identify larger, meaningful chunks to focus on. Second, representing the steps as a continuous conversation, where the model sees its own previous outputs, improved performance. The only exception is proofreading, which intentionally starts fresh. These conversational turns also make it easy to ablate or modify individual stages. To test this framework, The authors use Gemini 1.5 Pro with greedy decoding. They focus on English into 10 target languages, including Chinese, Ukrainian, Russian, Japanese, Hebrew, Czech, German, Hindi, Icelandic, and Spanish. WMT 2023 serves as the development set for prompt design and ablations, while WMT 2024 is used for final testing. Because the goal is long-form translation, they reconstruct documents from WMT segments, keeping them within the token limits of modern neural evaluation metrics. For evaluation, they rely primarily on metric X23, both its reference-based and quality estimation variants, and report tri-fifth scores in the appendix for completeness. When you look at the overall numbers, the pattern is clear. Translating step-by-step yields better quality than a single zero-shot prompt. Using metric X23, where lower scores indicate better translations, the multi-stage pipeline consistently beats zero-shot across all 10 language pairs and across the WMT 2023 and 2024 datasets. These improvements are not just marginal, they're large enough to push the system to state-of-the-art performance on WMT 2024's long-form translation tasks. To understand where the gains come from, the authors run a detailed ablation study on WMT 2023. They systematically turn individual stages on and off, and compare the resulting systems to a zero-shot baseline using both variants of metric X23. This lets them isolate the contribution of pre-translation research, drafting, refinement, and proofreading. The outcome is that every stage helps, but some are more critical than others. One key finding is that simply asking the model for a draft, even with a better prompt, is not enough. When the drafting stage is used alone, without pre-translation research, the improvements over zero-shot are small and often not statistically significant, and can even regress. But when drafting is combined with the research stage, the system consistently beats zero-shot by a meaningful margin. For most languages, these gains are highly significant under the reference-based metric X23. This strongly suggests that the explicit research step, getting the model to think about tricky phrases before translating, is a major driver of quality. The refinement stage also plays a crucial role. No matter what translation it starts from, zero-shot, a single-turn draft, or a research-informed draft, refinement consistently improves quality. The biggest gains come when refinement is applied after the research and drafting stages, showing that these steps are complementary. Proofreading, the final stage, adds more modest improvements on average, and its impact varies by language. Ukrainian stands out as clearly benefiting from proofreading, while other languages see smaller or mixed changes. Overall, the combination of research, drafting, and refinement does most of the heavy lifting, with proofreading providing a final polish. Crucially, these patterns are not just artifacts of the development data. On the WMT 2024 test sets, the same step-by-step recipe shows the same behavior. Research plus drafting beats zero-shot. Refinement adds another clear boost, and proofreading nudges quality a bit further. This holds across almost all of the evaluated language pairs, and both the reference-based and QE-based versions of metric X23 tell a consistent story. That gives confidence that the approach generalizes beyond the data used to tune the prompts. The authors also break down results by domain on WMT 2024: literary texts, news, social media, and speech. Step-by-step translation outperforms zero-shot in every domain, but the size of the gains varies. Social media, with its slang, humor, and informal style, sees the biggest improvements, which makes sense given the emphasis on pre-translation research and refinement. Speech transcripts show the smallest gains, possibly because the ASR-based input is noisier and less structured. Still, the method is robust. It never collapses back to zero-shot performance in any domain. This slide highlights the domain-level comparison between zero-shot and step-by-step translations. Each point shows how much the step-by-step system improves over zero-shot for a given domain and stage. You can see the steady progression from zero-shot to research-informed drafts, to refined, and finally proofread translations, with social media in particular benefiting from the full pipeline. To put these gains in context, the authors compare their method against several strong baselines. One is MAPS, a system that generates multiple candidate translations, conditioned on different types of background information, then uses an external QE model to select the best. They also compare to segment-level, zero-shot translation, both with and without access to the full document in the prompt. Finally, they benchmark against Unbabel Tower 70B, which was the top-performing system in early WMT 2024 rankings. These comparisons focus on English to German, Chinese, and Japanese, where MAPS has released prompts and examples. Even at the research plus draft stage, the step-by-step system is competitive with maps, often landing in the same statistical significance cluster. When you add refinement and proofreading, the gap widens. The final step-by-step system improves metric X23 scores over maps by roughly half a point or more in German, Chinese, and Japanese. That's notable because maps has an inherent advantage. It uses a QE model from the same family as metric X to pick its best candidate. In contrast, the step-by-step pipeline relies solely on Gemini's internal knowledge during translation and still comes out ahead. The segment-level baselines tell a similar story. Translating each segment independently, even with the full document provided as context, falls significantly short of the final step-by-step system. The gap is often more than 0.4 to 0.7 metric X points. When compared to Unbabel Tower 70B, the step-by-step approach achieves statistically comparable or slightly better performance in German and Chinese, and a clearly better score in Japanese. This is especially impressive given that Unbabel's system uses external QE metrics and more complex decoding strategies, while the step-by-step method sticks to greedy decoding and no external tools. To understand what the research stage is doing, the authors manually inspect examples, especially for English to Chinese. They find that Gemini is often very good at interpreting slang, figurative language, and jokes. For instance, it correctly understands cheeked up as having full cheeks in the context of miniatures, and explains that the weather didn't cooperate is a figurative way of saying conditions weren't suitable. However, the model can also be over-enthusiastic, labeling phrases as problematic when a literal translation would be fine, or adding slightly odd cultural commentary, like over-explaining the texture of bubblegum for a Chinese audience. Looking at full translation examples, the step-by-step pipeline often produces more context-appropriate outputs than both zero-shot and even the human reference. In one case, it correctly interprets threading as a social media thread, while the reference and zero-shot misinterpret it. The refinement stage is especially effective at removing translationese and making the text sound natural in the target language. However, it's not perfect. There are cases where refinement introduces hallucinated details that weren't in the source, like adding a mention of touching a bruise that never appears in the original. This highlights a familiar trade-off. As we push for more fluent, human-like text, we also increase the risk of subtle inaccuracies. The authors also report KRF scores, a character engram overlap metric. Interestingly, step-by-step translations often get lower KRF scores than zero-shot, even when metric X23 and qualitative analysis say they're better. This happens because KRF rewards staying close to the reference surface form, while the step-by-step pipeline explicitly encourages more fluent natural rephrasings. Neural metrics like metric X23 are better aligned with the balance of adequacy and fluency that humans care about. This pattern matches what other human-like LLM translation strategies have observed. There are several important limitations. First, the evaluation is almost entirely based on automatic metrics. While metric X23 is strong, it can't fully replace human judgment, especially for nuanced aspects of style and meaning. Second, because many neural metrics have limited context windows, the authors rely on a single metric family for long documents. Third, the entire pipeline is developed and tested only with Gemini 1.5 Pro. Different LLMs may follow instructions differently across languages, so we don't yet know how well this approach transfers to other models. From an ethical standpoint, the authors highlight a key concern. As the pipeline moves from faithful drafting to more fluent refinement and proofreading, the risk of hallucinations increases. A translation that reads smoothly but subtly distorts the source can be more dangerous than a clunky but accurate one, because users are more likely to trust it. This underscores the need for careful deployment, user education, and possibly additional safeguards to help people calibrate their trust in machine translation outputs. To wrap up, this work shows that reframing translation as a structured four-step process, research, drafting, refinement, and proofreading, can substantially improve long-form translation with large language models. The pre-translation research and refinement stages are particularly powerful, and the full pipeline can match or surpass systems that rely on external QE tools and more complex decoding. Perhaps the most important message is that LLMs are capable of progressively improving their own outputs when guided through a well-designed sequence of prompts, moving us beyond the old view of machine translation as a single monolithic mapping.